Hello and welcome to Solving Equations Using Factoring. When you're solving an equation, what you're actually finding is the root, zero, or solution to an equation. So what is a root, zero, or solution? Well, they're actually all the same thing. You're simply solving the equation. And when you solve the equation, you are finding where the graph intersects the x-axis. So if you look at this graph right here, and you look, this is the x-axis, where does this beautiful cubic graph hit the x-axis? Well, it hits it in 3 spots. Those 3 spots are here, here, and here. So when they hit the x-axis, the coordinates for the solutions are -3, 0, 0, 0, and 3, 0. Notice that the y-coordinate for each one of these coordinates is 0. So because all of the coordinates are 0, that's another way to think about how you're solving. You are solving to find all the values of x when y equals 0. So whenever we write the answers or solutions to an equation, we don't put the y equals 0. We simply put, say for this one, the solutions would be -3, 0, and 3, because we already know the values of x, and we already know that the answer will be when y equals 0. So, just as a quick reminder, which axis has the equation y equals 0? Well, that's got to be the x-axis, because here, every single coordinate on that line has a y-coordinate of 0. So, you will be learning how to do this over the next couple days in your calculator. Your calculator is a wonderful way to check whether your answer is correct. Unfortunately, this is algebra, and we have to solve these algebraically and not in a calculator. So whenever we solve an equation, we are trying to find the roots of its graph. So when we do that, we have a special, we could call it a trick, but it's really the only way to do it, so it's not really a trick, it's the way to do it. We use the multiplicative property of 0. And all that means is that anything, excuse me, times 0 is always going to be 0. So if you take your anything, we don't really care what that is, one of the values always has to be 0 when you're multiplying to equal 0. So if you look here, our 4 here and our 22 are your anything. And we need that x to be 0 in order for this whole equation to be true. So that is all that the multiplicative property of 0 is stating, that if your answer is 0, something's got to be 0 when you're multiplying. There we go, sorry. So if we want to solve something that looks like this, 0 equals, here I can zoom out, zoom in. 0 equals 2 times x minus 3 times 3x minus 6. You'll see we have 2 as a factor, x minus 3 as a factor, and 3x minus 6 as a factor. Now when we look at it, it looks like there's 3 factors, and there are, but there aren't going to be 3 answers for x. Because if you look here, we would set each one of these equal to 0, and you see, can 2 ever equal 0? No, that's crazy talk. But x minus 3 could be 0, and we solve that. And x equals 3, and also 3x minus 6 could be 0. So we solve this, normal solving methods. And we have two solutions. X could be 3 and x could be 2. The curly brackets are optional, not really necessary. As long as you have x equals 3, x equals 2, you have solutions to the equation. So if you plugged 3 into that equation, you get 0, and also if you plugged 2 into this equation, you would get 0. So that's just saying there are 2 solutions to this equation. Awesome. Awesome. Alrighty, next page. Alright, looking at this one, what are the roots of this equation? Now what you're going to see is that this is slightly different from the last equation because the y over here is there. Okay, in the other equations y wasn't there. So sometimes they're going to ask you to solve and the 0 will already be there, and sometimes there'll be a y. If the y is there, you simply say, okay, y is 0, let's move on and solve the equation. Because we know when we're solving for roots, solutions, or zeros, the y value is always 0. So we simply plug in 0 for y. I'm going to rewrite this, giving myself more room. Okay, and then we simply say, okay, there are 4 factors. Each of these factors could be 0. Let's see what value I would get for x if they were 0. So we would just set 2x minus 3 equal to 0 and solve. Divide by 2, and x is 3 over 2. This one we set x plus 7 equal to 0. That's an equal. Subtract 7, x equals negative 7. Yes, you should do this particular step here and show the work. However, you could just go x equals negative 1. We really don't mind. Okay? What we do mind is when you have an equation like this, 5x minus 1 equals 0. You should solve this one because getting an answer out of the top of your head can be very difficult, especially because they're awesome fractions. So remember, write decimals. Don't write decimals. Always write your fractions unless they say or they tell you where to round to. So there are all the solutions to that particular equation. So, what happens when it isn't already written all nice and perfect like factors? So this one right here had factor, 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 factor. Maybe I'm giving you the answer that I'm looking for. What happens when it isn't all multiplied together? How can we fix it so that it is? Yes, that's right. We factor. Shocking. I just said factor 75 times. Okay, so I do notice here that the y isn't 0, so make it 0 first. If you want to factor at the same time, you also may factor. But then we factor. And we just did a whole thing on factoring, so this should be pretty straightforward. Careful for this one, 3 and 2 don't work because they have to multiply to a negative 6. If you were going to use 3 and 2 to add up to a negative 5, it would be negative 3 and negative 2, and that multiplies to a positive 6. So please watch that. This is a very common one they write. And we ask you this one all the time. So make sure you're checking your factors. So your two solutions here are x equals 6 and x equals 1. Well, that's a 1. Or negative 1. Alright, make that nicer. What is the graph of this equation called? Do you remember? Do you remember what a quadratic looks like when you factor it? And remember what the actual graph is called. I'll say this a few times throughout the run of the program. Let's see if you can pick it up. After y equals 0, we factor the equation so that we can use the multiplicative properties of 0. And then we solve the equations that are created. So that's what we do every single time. The basic idea is Set y equal to 0, factor, t-chart, we're done. Uh-oh. This particular one, there is no 0, and there is no y, just to get so that we have a 0. So we simply create an equation and solve it so that, look, it's nice and factorable. Put everything onto one side, so we put everything on one side. Okay, and we do that by adding its opposite. So to move this -3 to the other side, it's just like solving an equation. If you're going to move something to the other side of an equation, we change its sign. And now we have to factor this. I'm not going to go over the factoring part of it because, you know, we just did that yesterday or 2 days ago. So I will actually do it though. So this is 2 times -3, we get -6, or we do -6x squared. Two things that multiply together to -6 and add to 1 are positive 3x and -2x. Right? So it's 0 equals 2x squared, blowing out the middle here. Okay, then we factor by grouping. So the GCF there is x, and we're left with 2x plus 3. The GCF here is -1, and we're left with 2x plus 3. So 2x plus 3 and x minus 1 are our factors. And then we simply t-chart, and we're good to go. Bam! 2x plus 3 equals 0. Subtract 3. Ooh, can I go to the next page? Oh, that was exciting. Look at that. X equals -3 over 2, and x minus 1 equals 0, and x equals 1. So the solutions to this equation, that's my curly bracket, is -3 over 2, and a positive 1. Oh, curly bracket. That is the answer. Next. All right, how many possible real solutions are there for the following equation? Sorry. Real solutions. A real solution is basically you don't have a negative under a radical. What that means, we're going to discuss in a few days. So here is the basic idea of what I'm saying is when we're talking about this equation is how many possible solutions are you going to have? To figure that out, you'll just look at the degree of the equation. What is the degree of this equation right here? Well, remember when we said degree, that's always the highest exponent. So it's important you remember that. That's why we went over that before, exponent. So the highest exponent in this entire equation is 4. So in the end, we could have a possibility of having 4 answers. So it's good to know, you could have 4. If you have 5, something went wrong. So to solve this, the process is the same. I don't really have to say much. All we have to do, get everything to one side. So whenever we get everything to one side, the leading coefficient, this is just awesome vocab here, the leading coefficient needs to be positive. Now remember, the leading coefficient is the coefficient that's on the term with the highest exponent. So this right here is our leading term, and the leading coefficient here is positive, so that one's going to stay. And these two here, these guys are going to move to the other side. So in order to move them, okay, I simply change their signs. I'm going to do them both at the same time. So this side is the side that's going to be 0, and we're going to be left with x to the fourth minus 5x squared plus 4. And then we factor and solve every single time. Same process. We just have to use all of our skills of factoring. So here, when we first factor, we know we use x squared going here and here. Two numbers that multiply to 4 and add to -5, so that would be -4 and -1. And that's allowed because remember this is a 1 here. Anytime the leading coefficient is 1, the two numbers that we get can be just written there and there. We t-chart this and we solve each of these individual equations. So we do x squared minus 4 equals 0. And we're going to do x squared minus 1 equals 0. So fortunately or unfortunately, depending on how much you love math, you actually have to factor this guy again. So it's x minus 2, x plus 2, and you have to solve this over again. So here x is going to be 2, and x is -2. Again, we'll do the same thing with this one. This is another dots, x plus 1, x minus 1. T-chart, x equals -1, x equals 1. I just ran out of room, so I couldn't put those extra steps. So the solution here, remember there was a possibility of having 4 answers, and that did happen. So 2 and -2, -1 and 1. Doesn't matter the order you put them, they're all good the way they are. How many possible real solutions for this one? Well, look at that. The highest degree is 3, so we could have a possibility of 3 solutions. Now we need to find them. So remember, the leading coefficient needs to be positive. So the leading coefficient is on that term. That term is negative, so this is the one that's going to go to the other side. Leading coefficient always has to be positive. So we'll move this to the other side, 4x cubed. And we like to put it in descending order. That means the highest one with the highest exponent goes first. That's the lead. Then the next highest exponent, which is this guy, goes next. And then, you just keep going. So the next one is 6x, and that ends it. So now we solve this. Again, factor t-chart done. So I look here. Remember, the first step you always have to do is looking for your GCF. Now there's a GCF, definitely. I'm changing color there. 2x is a GCF for this. And when I factor out that 2x, I'm left with 2x squared minus 7x plus 3. So we have our 2 factors. We t-chart, set each of the factors equal to 0, and solve each one of them. Some of them are easier than others. Obviously, some of them are harder. This one, 2 times x is 0. Well, then x has to be 0. If you need to, you can, of course, divide by 2, but there's no other way. This one over here, there's no GCF in that anymore, so we have to factor that. It's the, what is it, earmuff, guess and check, or what do they call it, AC, first letter. There's so many names to it, I don't care. So just multiply this guy times this guy, and you get 6x squared. 2 numbers that multiply to 6, add to -7 are -6x and -1x. Blow out the middle here. 2x squared minus 6x minus 1x plus 3 equals 0. Factor by grouping, 2x, x minus 3, -1, x minus 3. So our 2 factors, can I erase? Yeah, excuse me. I'm going to bring it up to the top there. So our 2 factors are x minus 3 and 2x minus 1. T-chart those. x minus 3 equals 0. Again, optional step, but it's good to do. This one here, you have to put this because solving it isn't as straightforward as we want it to be. And our two solutions are, oh, our three solutions. Look at that, I almost lost this one. We have this one, and this one. But this is a good thing. As long as you've done x equals 0, your answer is there. So you don't have to worry about writing it in little curly brackets. It's really unnecessary because all three answers are there. Let the person grading it find it. You did it. So it's a good lesson right there. So what you may want to do with this one, pause, see if you can do this on your own, and then if, do your best and solve it. You'll have to pause. Okay, maybe you've paused it, maybe you're just making me do the work. It's alright, I'm going to do it anyway. So I notice y is 0, so I'm going to get y equal to 0 there. Y isn't 0, so we're going to get y equal to 0 there. Right? I notice there's 4 terms. Anytime there's 4 or more terms, factor by grouping. So factor those two. Factor those two. These two are the same, so that's the GCF there. And you can put the 0 on either side. It doesn't make any difference. Some people don't like it when I do that, so we'll put it there. We t-chart. X equals -1, and then here x squared plus 3 equals 0. Are you scared? Okay. This is what we were talking about, real zeros. We want to find all real zeros. This one, there is no number I can put in for x squared that we know of yet that could get rid of the -3. So there's no way that if I subtract 3 from both sides, that x squared could ever be a negative number. It can't be done. That's not a real answer. So this one doesn't matter. We could have had 3 answers. We could have, but we didn't. We just had 1. That's okay. It's no big deal. It's just the way it is. And then finally, there's this one. You're welcome to stop this thing and stop torturing yourself. However, I am going to go through and do this one. You pause it to see if you can. All of the solutions, I believe, for this one actually work, so please feel free to stop this right now. Stop the torture. Alright, so I'm going to do this one, and then we're good to go. So I noticed there are going to be 3 solutions, 3 real solutions possibly. The leading coefficient on this is positive, so I am going to move these to the other side. So by subtracting the x and subtracting the 2. So this side is 0, and we're left with x cubed plus 2x squared. And I'm doing this in descending order. Remember, so descending order means that the exponent's 3, then 2, then 1, then 0, and you're done. 4 terms. Factor by grouping, x squared here, and we're left with x plus 2, -1 here, x plus 2, so x plus 2 is the GCF there, and x squared minus 1 there. Equals 0 can go on either side. We t-chart, set x plus 2 equal to 0, and x squared minus 1 equal to 0, and solve each of these equations. So x equals -2. And then this one can be solved. Now this is dots. X plus 1, x minus 1 equals 0. T-chart, x equals -1, and x equals 1. Like, I skip that step all the time. It's not a big deal if you do. It's just if you have a fraction for an answer, you're going to want to have the solution written. So x is -2, -1, and 1. I hope you enjoyed it. It was a little long, but it's all good. It's practice factoring. Have a great day. Bye.